Hello there, thank you for tuning in to my channel. In this video, we are going to be looking at binomial expansion questions from 2020 papers. I've prepared a worksheet with these questions, so you can find the link in the description below. Thank you for watching, and let's get started. The coefficient of 1 over x in the expansion of 2x plus a over x squared all to the power of 5 is 720. So on A, find the possible values of the constant a. Now, here, we're going to use the formula for the general term of a binomial expansion. So we're saying for the expansion of a plus b to the power of n, the general term, the r plus 1th term, should be n choose r, a to the n minus r, b to the r. So this is what we're going to use for this question. So in this case, 2x is a, and b is represented by a over x squared, with the power n being equal to 5. So we can say the general term, ur plus 1 for this expansion, is 5 choose r, 2x to the power of n minus r, which will be 5 minus r, and b to the power of r, which is a over x squared to the power of r. So this is the general term for the binomial expansion of 2x plus a over x squared all to the power of 5. So I can actually split this into coefficients and also x terms. And for the coefficients, I'll take 5 choose r, all the terms that are without x. So 5 choose r. Then here I'll take 2 to the power of 5 minus r. So that's 2 to the 5 minus r. And for here, I'll take a, which is the constant, raised to the power of r. So that's a to the power of r. And then for the x terms, I'll only have x here to the power of 5 minus r. And here I'll be having 1 over x squared to the power of r. So I'll simplify this expression for the x terms. So that'll be x to the power of 5 minus r, and 1 over x squared, that's x to the power of minus 2 raised to the power of r. So it'll be like this. So we can apply the laws of indices. 5 minus r will add to minus 2r. So it becomes 5 minus 3r. So this here is the general expression for the x terms of the binomial expansion of what we have here. But here the term of concern is the term in 1 over x. And 1 over x is actually x to the power of minus 1. So we can say we want the term where the general term is x to the power minus 1. And here we can equate the powers. So 5 minus 3r is equal to minus 1. So minus 3r is equal to minus 6. So r comes out by dividing both sides by minus 3, comes out as a 2. So the term here that we want is r being equal to 2. So since we now know that r is 2, and they say the coefficient of that term is 720, then I'm going to substitute r is equal to 2 into this and equate it to 720, since this gives us the coefficients. So the coefficient will be 5 choose 2, 2 to the power of 5 minus 2, so that will be 2 to the power of 3, and a to the power of r, which is 2, is equal to 720. So 5 choose 2 is 10, and 2 cubed is 8, so that's a squared is equal to 720. So basically we have 80a squared is equal to 720. So we can divide both sides by 80 to get a squared is equal to 9. And if we square root both sides, we get a coming out as plus or minus 3. So the two possible values of a are a is equal to plus 3 or a is equal to negative 3. And that's the answer for this question. We can scroll down to part B. Hence find the coefficient of 1 over x to the power 7 in the expansion. So here we're talking about the coefficient, and we obtained a general form for the coefficients, and we got it as this. So I'm going to take this general form for the coefficients. I'll take it down. And here it is. And we also have the general term for the x terms, which simplified to x to the 5 minus 3r. So I'll also take this. So this is the general term for the x terms. And it's x to the 5 minus 3r. So the x term here is 1 over x power 7. So we're saying x to the power of 5 minus 3r should be equal to x to the power of minus 7, which therefore means 5 minus 3r is equal to minus 7. Subtracting 5 from both sides, we get minus 3r is equal to minus 12. And dividing both sides by minus 3, we get r equal to 4. So the coefficient of 1 over x to the power 7 occurs when r is equal to 4. So for the coefficient now, for the answer, it will simply be 5 choose 4, 2 to the power of 5 minus 4 times a to the r. Remember, we got a as plus or minus 3. So that will be plus or minus 3 to the power of r, which is 4. So 5 choose 4 is 5. That's 5 times 2 times 3 to the power of 4 is 81. So 5 times 2, that's 10, and 10 times 81 is 810. So this is the solution. This is the coefficient of 1 over x power 7 in the expansion. That's the answer. Question number 2. The coefficient of 1 over x in the expansion of kx plus 1 over x to the power 5 plus 1 minus 2 over x to the power of 8 is 74. Find the value of the positive constant k. So here, let's start with kx plus 1 over x to the power of 5. Now we know that the general term in the expansion of a plus b to the power of n is u sub r plus 1 is equal to n choose r, a to the n minus r, b to the r. Now for kx plus 1 over x to the power of 5, the general term will be 5 choose r, and kx to the power of 5 minus r, which is 5 minus r, and 1 over x to the power of r, like this. So we can deduce the coefficients in the general expansion as 5 choose r, that's the constant, and here we can have the constant k raised to the power of 5 minus r. So these are going to be the coefficients. And the x terms in the expansion are going to be only x to the power of 5 minus r, and also here 1 over x to the power of r. And this can be simplified: x to the power of 5 minus r times x to the power of minus r, which is basically x to the power of 5 minus 2r if we add the powers. So all the x terms in the binomial expansion of kx plus 1 over x to the power of 5 take the form x to the power of 5 minus 2r. But now, since the x term is 1 over x, or x to the power minus 1, we can equate this to say x to the power of 5 minus 2r is equal to x to the power of minus 1. And therefore, equating the powers, so 5 minus 2r is equal to minus 1. And we can solve for r. That's subtracting 5 from both sides becomes minus 1 minus 5, which is minus 6, and dividing by minus 2, we get r as 3. So the term that we want occurs when r is equal to 3. So the coefficient will come out as 5 choose 3, and k to the power of 5 minus 3, which is k squared, and 5 choose 3 is 10, so we'll get the coefficient of 1 over x to be 10k squared. So that's how we can find the coefficient of 1 over x in the binomial expansion of kx plus 1 over x to the power of 5. Now for the expansion of 1 minus 2 over x to the power of 8, so for 1 minus 2 over x to the power of 8, we can make use of the formula from the formula sheet for the expansion of 1 plus x to the power of n. So this is taken from the formula booklet. So it's likely that the term in 1 over x is going to come out as the second term, which is nx here. So by expanding, nx will simply be n, which is 8, of x, which is in this case minus 2 over x. And this gives us minus 16 over x. So the term in 1 over x is the second term in the expansion of 1 minus 2 over x to the power of 8. And this happens to be minus 16 over x. So this can be expressed as minus 16 of 1 over x. And therefore the coefficient is simply minus 16. So we now have two coefficients. We obtain the first coefficient as 10k squared. So 10k squared, and the second coefficient as minus 16. So this should be equal to, according to the question, this should be equal to 74. So it's all equal to 74. So I'll add 16 to both sides, so that's 10k squared is equal to 74 plus 16, and that's 90. Dividing by 10 both sides, we get k squared is equal to 9. And square rooting both sides, we get k is equal to plus or minus 3. However, from the information in the question, they want us to find the value of the positive constant k. So k should be positive, and therefore the value of k that we want is 3. And that's our answer here to question number 2. Find the coefficient of x squared in the expansion of x minus 2 over x all to the power of 6. Now for this one, we can start with the general expression for the binomial expansion of a plus b to the power of n. That's ur plus 1 is equal to n choose r, a to the n minus r, b to the r. Which means for this binomial, a is x and b is minus 2 over x, and n is the power 6 here. So we are saying the general expression will be UR plus 1 is equal to 6 choose R and x to the power of 6 minus R and B, which is minus 2 over x to the power of R. Now I can split this into constants as well as x terms. So for the constants or the coefficients, we will be having 6 choose R, and we also have minus 2 here to the power of R. So these are the constants or the coefficients. And then we also have the x terms. And for the x terms or the terms in x, in this expression, we have x to the power of 6 minus R. And we also have from here, that's 1 over x, which is x power minus 1. So times R, that's x to the power of minus R. And this can be simplified to x to the power of 6 minus 2R if we add the powers right here. So we now have the general forms for all the coefficients in the binomial expansion and all the x terms in the binomial expansion of this. Now, if we are going to get a coefficient of x squared, it means the x term, which is x to the power of 6 minus 2R, is x squared, which therefore means that equating the powers, 6 minus 2R should be equal to 2. That's minus 2R is equal to minus 4. So we can solve for R coming out as 2. So we now know that for the term in x squared, R is equal to 2. So therefore, the coefficient of x squared should come out as, using this expression, that would be 6 choose 2 and minus 2 to the power of R, which is 2. Now we know that 6 choose 2 is 15, and minus 2 to the power of 2, that's 4. So we get the answer coming out as 60. So that's what we get there for the coefficient of x squared. Let's scroll down to part B. Find the coefficient of x squared in the expansion of 2 plus 3x squared bracket x minus 2 over x to the power of 6. Now, we are multiplying two brackets here, and we know that in our process of multiplying, 2 is going to multiply the second bracket, and from there, we should get a term in x squared. So what kind of term should 2 multiply in the second bracket to give us a term in x squared? So we know that it should be a term in x squared. So it's 2 times a term in x squared. And we also know that 3x squared is going to multiply the second bracket, and that's plus 3x squared. And what should 3x squared multiply in the second bracket to get a term in x squared? Since x squared is already here, it means there has to be a constant term that we should multiply 3x squared with to get a term in x squared. So it's a constant or a term that is independent of x. So we already have a term in x squared in the binomial expansion of x minus 2 over x to the power of 6, and we obtained it already as 60. So we've got 60x squared as the term in x squared. So this part we already have. So what we now need to find is a constant or the term independent of x in the binomial expansion of x minus 2 over x to the power 6. So we're saying for the term independent of x, we know that the x term, since it's a term independent of x, it should be x to the power of 0. Because x power 0 is 1, and that's a constant, that's a unit constant. So the general expression for the x terms, we got it to be x to the 6 minus 2r. So x power of 6 minus 2r should be equal to x power 0, which means 6 minus 2r is equal to 0 by equating the powers. And if we are going to solve for r from this little equation, we get r coming out as 3. So we now have r equal to 3, which therefore means the term independent of x is going to be, using the formula for the coefficients, that's 6 choose r and minus 2 to the power of r. So it's 6 choose 3 and minus 2 to the power of 3. That's the coefficient. And that's the term independent of x. This gives us 6 choose 3 is 20. And this times minus 2 to the power of 3, that's minus 8. And this gives us minus 160. So we now know the term independent of x here to be minus 160. So it therefore means that the term in x squared should come out as 2 of a term in x squared, which we said we got as 60 here. So that's 60x squared. And then that's plus 3x squared times the constant, the term independent of x, that's minus 160. So this gives us 2 times 60, that's 120x squared, and 3x squared times minus 160, that's minus 480x squared, and this gives us 120x squared minus 480x squared is minus 360x squared, and therefore our answer is minus 360. That's the coefficient of the term in x squared. Question number 4. Expand 1 plus a to the power 5 in ascending powers of a up to and including the term in a cubed. So for this one, I'll make use of this binomial expansion of 1 plus a to the power of n from the data booklet. So I'll say, since we have 1 plus a to the power of 5, so it's 1 plus a to the power of n is equal to 1 plus nx going all the way. So I'll say 1 plus a to the power of 5 is equal to 1 plus nx. So that would be 5 of a plus n of n minus 1. So that would be 5, 4 over 2 factorial of a squared. That's x squared. Then that's plus n of n minus 1 of n minus 2. So that's 5, 4, 3 over 3 factorial of x cubed. In this case, x is a, so that will be a cubed. So I can now just simplify this. So that's 1 plus 5a plus 5 times 4 over 2 factorial. That's the same as 5 times 4 over 2 times 1. That's 2 factorial. So I can divide 2 into 4. So 5 times 2, that's 10. So I'll be having here 10a squared. Then that's plus 5, 4, 3 over 3 factorial. That's 5 times 4 times 3 over 3 factorial is 3 times 2 times 1. So 3 into 3, that's 1. 2 into 4, that's 2. So 5 times 2, that's 10. So that's 10a cubed. So this is what we have eventually. That's the answer to part A. Let's go on to part B. Hence expand 1 plus x squared in brackets to the power of 5 in ascending powers of x up to and including the term in x cubed, simplifying your answer. Okay, So here they're saying hence, which means that we're going to use what we have already come out with from part A. On part A, we expanded 1 plus a to the power of 5 here. So that was 1 plus a to the power of 5, and it came out to be this. So we want to make use of the same expansion, because if you can notice, when we have 1 plus x squared to the power of 5, apparently you can see that a has been replaced by x plus x squared, but the binomial expansion is the same. So I'm going to substitute x plus x squared for a in this expansion. So this is going to give me 1 plus 5a, which is 5 of x plus x squared. And that's plus 10a squared, which is 10 of x plus x squared squared. And then that's plus 10a cubed, that's 10 of x plus x squared cubed. So we're going to simplify this, and remember, we want the powers up to and including the term in x cubed. So let's simplify. So this will give us 1 plus 5 times x, that's 5x, 5 times x squared, that's 5x squared. Then that's plus 10 of, and then we expand x plus x squared squared. So that's x squared plus 2 times the product of this 2, so that will give us 2x cubed. And then that's plus x to the power of 4 as x power 4. Then that's plus 10 of, and then here we want to expand x plus x squared cubed, which I can say is the same as x. This part is x plus x squared of x plus x squared squared. That's the same as x plus x squared cubed. So I can do it this way. I can say that's 10 of x plus x squared bracket, and x plus x squared squared is what we've already obtained here, which is x squared plus 2x cubed plus x power of 4. So this is what we have. So here I'm just going to collect the terms up to and including the term in x cubed. So let's do that. So 1 plus 5x plus 5x squared are all okay. Then that's plus 10 times x squared, that's 10x squared. Then 10 times 2x cubed, that's 20x cubed. But I will not take 10 times x power 4 since it's greater than x cubed. So that's plus, and here I have the 10 already. Then x is going to multiply this bracket. So x will multiply x squared to give us x cubed. But x, if it multiplies the other terms, it will get something that is higher than x cubed. So we'll leave those results out. And x squared, if it multiplies all these terms here, it will give us also something that's greater than x cubed. So we'll only take x cubed here. So we can now simplify this to 1 plus the terms in x, we only have 5x. Then the terms in x squared, we have 5x squared and 10x squared. So that gives us 15x squared. And the terms in x cubed, we have 20x cubed and 10x cubed, and that's 30x cubed. So these are the only terms in ascending powers of x up to and including the term in x cubed. That's our answer right here. Question number 5. In the expansion of 2x squared plus a over x all to the power of 6, the coefficients of x to the power 6 and x cubed are equal. So on a, find the value of the non-zero constant a. So here we are going to consider the general expansion or the general form of the binomial expansion a plus b to the power of n, which comes out as n choose r, a to the n minus r, and b to the power of r. So in our case here, we'll be saying the general form for the terms in the binomial expansion of this should be 6 choose r and 2x squared to the power of 6 minus r and a over x to the power of r. So now we can split this into coefficients and also into x terms. Now for the coefficients, we are going to take the constants only from this. So that will be 6 choose r, and here we take the 2, so that's 2 to the power of 6 minus r, and here we take a and raise to the power of r, so that's a to the power of r. And for the x terms, I'm going to take only the terms in x, so that will be x squared, and that's raised to the power of 6 minus r, and here we have 1 over x, and it's raised to the power of r. So this can be simplified to x to the power of 2 times 6 minus r, that will be 12 minus 2r, and it's multiplied by 1 over x is x to the power of minus 1, and that power minus 1 multiplies r to get x to the power of minus r. So this comes out as x to the power of, adding the powers, we get 12 minus 3r. So we now have the general form for all the x terms in the binomial expansion and the coefficients in the binomial expansion of 2x squared plus a over x to the power of 6. Now for the term in x to the power of 6, we can now say x to the power of 12 minus 3r, which is the general x term, is equal to x to the power of 6, which therefore translates to 12 minus 3r being equal to the power 6. We're equating the powers here. So we can solve for r, and r comes out as 2. And now we can say for x to the power of 3, for x cubed, the x term, which is x to the power of 12 minus 3r, should be equal to x to the power 3, which therefore translates to 12 minus 3r being equal to 3. So if we solve for r from this small equation, we get r coming out as 3. So we now know the value of r for the term in x power 6 and the term in x cubed. According to the question, the coefficients of x power 6 and x cubed are equal. So we're saying, since coefficient of x to the power of 6 is equal to coefficient of x cubed, then the coefficient of x power 6 occurs when r is equal to 2. So that's 6 choose 2 here, and that's 2 to the power of 6 minus 2, that's 4, and a to the power of 2, so that's a squared. That's equal to the coefficient of x cubed, which in this case r is 3, so that will be 6 choose 3, and that's 2 to the power of 6 minus 3 is 3, and a to the power of 3. So let's just make use of our calculator here. Let's start with 6 choose 2 times 2 to the power of 4. So that's 6 choose 2, and that's multiplied by 2 to the power of 4, that's 16. And this gives us 240. So we have 240 a squared here. And again, we are going to say 6 choose 3 multiplied by 2 to the power of 3, which is 8. So we get 160. So that's equal to 160 a cubed. So I can now solve for a. And how I'm going to do that is I will divide both sides by 160 a squared. So that means that here on the right side, the 160 and the 160 will cancel. And if we divide a squared into a cubed, we get a to the power of 1. And on the left side, I can divide a squared into a squared, and we get 1. And 240 over 160 is what remains. So that's 240 over 160. Now this can be reduced to 3 over 2, because 80 gets into here 2 times and 80 gets into here 3 times. So it therefore means that a comes out as 3 over 2. And that's the solution to part A of the question. Let's go to part B. Find the coefficient of x power 6 in the expansion of 1 minus x cubed bracket 2x squared plus a over x to the power of 6. So for this one, we are saying to get the coefficient of the term in x power 6, when we expand these two brackets, it means along the way as we expand, 1 is going to multiply the second bracket. And for us to get a term in x power 6, 1 should multiply a term in x to the power 6 minus x cubed. Will also multiply the terms in the binomial expansion. And for us to get a term in x power 6, x cubed must multiply a term in x cubed. So this is what's going to give us a term in x to the power of 6, from which we can take the coefficient. Now for the term in x power 6, we are saying is 1 times the term in x power 6 of this binomial expansion. We had already worked out that for x power 6, r is 2. And when we simplified it, the coefficient came out to be 6 choose 2 to the power 4a squared, which was 240a squared. So that's the coefficient right here. So we have 240a squared, and that will be x to the power of 6. And that's minus x cubed, and the term in x cubed in the binomial expansion, we had gotten the coefficient of x to the power 3 as 6 choose 3 2 cubed a cubed, which then came out to be 160a cubed. So that's what we're going to use here. So that will be minus 160a cubed, and that will be x cubed. So we can simplify this. So on the left side, we have 240 here, 1 times 240. And that's times a squared. A is 3 over 2, so that will be 3 over 2 squared. And that's x to the power of 6. That's minus. And here we're going to have 160. And then that's times a cubed, which is 3 over 2 cubed. And x cubed times x cubed, that's going to give us x to the power of 6. So let's simplify this. So we have 240 times 3 over 2 squared, and this gives us 540. So here we have 540 x to the power of 6, and that's minus, and that's going to be 160 times 3 over 2 to the power of 3, and again it gives us 540 x to the power 6. Now 540 x to the power 6 minus 540 x to the power 6 is going to give us 0. And that's the answer. So the coefficient of x to the power of 6 is just going to come out as a 0. And that's how we do it. The coefficient of x cubed in the expansion of 1 plus kx bracket 1 minus 2x to the power of 5 is 20. Find the value of the constant k. So here we're going to be using the binomial expansion for 1 plus x to the power of n, taken from the list of formula. So in this case, we have 1 plus kx multiplying the terms in the second bracket. But for the second bracket, we are only going to need the term in x squared and the term in x cubed, so that we can get the term in x cubed for the expansion. So here we're going to be having the term in x squared as n of n minus 1 over 2 factorial. N is 5, so that will be 5 or 4 over 2 factorial. And that's x squared. In this case, x is minus 2x, so we have minus 2x squared. And that's plus n of n minus 1 of n minus 2 over 3 factorial, which is 5 of 4 of 3 over 3 factorial of x cubed. X is minus 2x, so that's minus 2x cubed. So this is what we have for the terms in x squared and the term in x cubed. Let's just continue simplifying. So we have 1 plus kx here, and it's multiplying 5 times 4, that's 20. 20 divided by 2 factorial. 2 factorial is 2, so we get 10 here, and 10 times minus 2 squared, which is 4. This is going to give us 40x squared, and then that's plus, and here we have 5 times 4 times 3, which is 60, divided by 3 factorial, which is 6. So we get 10 here, and 10 times minus 2 cubed, which is minus 8. We get minus 80. So it's minus 80 x cubed. So these are the terms in x squared and terms in x cubed in the binomial expansion of 1 minus 2x to the power of 5. So expanding, we are going to get, just looking for the terms in x cubed, we will have 1 multiply minus 80 x cubed, and we get minus 80 x cubed. So we're just saying here terms in x cubed, we will only have minus 80 x cubed, and kx will multiply 40 x squared, and that will give us plus 40 kx cubed. So that's the term in x cubed. And actually, if we can factor out x cubed, that's like minus 80 plus 40k is equal, bracket x cubed. So that's the term in x cubed in the binomial expansion for those two brackets. So what we can now do is, since according to the question they say that the coefficient of the term in x cubed is 20, I can now equate minus 80 plus 40k to 20. So that means that we have 40k here, and adding 80 to both sides we have 100. Then we can divide both sides by 40, so k comes out as a 100 over 40, which is 5 over 2. And that's the answer right here. That's the value of k. In the expansion of a plus bx to the power 7, where a and b are non-zero constants, the coefficients of x, x squared, and x to the power 4 are the first, second, and third terms, respectively, of a geometric progression. Find the value of a over b. So right here, we're going to consider the binomial, that's a plus bx to the power of 7. And we know that the general term of this binomial expansion is going to be given by 7 choose r, a to the power 7 minus r, and bx to the power of r. So we can also express this as 7 choose r, a to the power 7 minus r, then b to the power r, and x to the power of r. So the first term should be 7 choose 1, a to the power of 7 minus 1, which is 6, and b to the power 1. So I'll just write the coefficient part of it. So this is what we have for the first term of the geometric progression. Then for the second term, this is the term which is the coefficient of x squared. So it means r is going to be equal to 2. So that's going to be 7, choose 2. And that's of a to the power of 7 minus 2, which is a to the power of 5. And then b to the power of 2. So that's b squared. So that's the second term of the geometric progression. Then for the third term, which is the coefficient of x to the power 4, it means that the power r is 4. So that's 7, choose 4, of a to the power of 7 minus 4, which is 3. And that's b to the power of 4. So we now have the 3 terms of the geometric progression. Now we can simplify this a bit. Now 7 choose 1 is 7. So it's 7 a to the power 6 of b. And 7 choose 2. 7 choose 2 is 21. So that's 21 a to the power 5 b to the power 2. And 7 choose 4. That's 35. So we have 35 here. A to the power of 3, b to the power of 4. Now, what we know about geometric progression is that if we divide a term by the one that is preceding it, we get r, which is the common ratio. So it means here, if we divide 21 a to the power of 5 b squared by 7a to the power 6 and b, this should be equal to 35 a to the power of 3 b to the power 4 divided by 21 a to the power of 5 b to the power of 2. So let's simplify this a bit. So 7 gets into 21 3 times. And a to the power of 5 divides into a to the power 6 to give us a to the power 1 at the bottom. And b gets into b squared to give us b to the power 1 at the top. So what we remain with on the left side is 3b over a. And on the right side, we know that if we divide 7 into 21, we get 3, and 7 into 35, we get 5. Then 8 power 3 into 8 power 5, we get 8 power 2 at the bottom. And b to the power 2 into b to the power 4, we get b squared at the top. So what we'll be having is 5b to the power of 2, and that's going to be over 3a squared. So this is what we now have. So what I'll do here is I'll multiply both sides by a over b. And if we do that, then here we cancel out, so we're left with 3. And here, dividing b into b squared, we get b to the power 1. So we have 5b. And a into this, we get 3a. And finally, to get the value of b over a, let's just multiply both sides by 3 over 5. And if we do that, then here we are left with b over a. So that's b over a. And here we'll be having 9 over 5. So therefore, a over b, the one we want, is inverting. We get 5 over 9. And this here is the final answer.